Hello, everyone. Welcome back to another video. This time we'll be talking about subnetting and how those subnetting decisions are made across an enterprise network. Mohammed, do you want to get us started onto the first slide?
Yes. So we can start with what is actually subnetting. Definition-wise, subnetting is the process of logically dividing a single network address space into multiple smaller network segments called subnets. What the technical process looks like, you take bits from the host portion of an IP address and convert them to network bits to create additional network boundaries which creates multiple broadcast domains from one large domain. This will make more sense as we progress through the PowerPoint slides.
Great. So why do we need subnetting? For one, it creates some segmentation benefits, such as broadcast domain deductions, which means it'll limit the broadcast traffic to subnet boundaries, security segmentation, as it implements network access controls between VLANs, and it'll make more sense as we progress as well when we begin talking about firewalls and how those firewall policies apply to IP addresses. Efficient address utilization. It optimizes IP address allocations. So something that we need to talk about before we go even further is IP addresses are not infinite. There is a limited amount of IP addresses that you can use, whether it is private or public, which if you don't know those terms, we will talk about them, but they are not infinite. So you need to optimize your allocations everywhere you can. Administrative boundarings, it creates logical network management zones. So often enterprise networks, they'll have what is called their management subnets and their data center subnets, their cloud subnets, and it'll all make more sense. Implementation examples. So the DMZ network isolation for web servers, management VLAN for network infrastructure, user VLAN separated by department or function, and point-to-point links between routers. You can move on to the next slide, Mohammed.
Yes. So we talked about bits earlier on the first slide. So first, to understand what bits are, we can cover some binary fundamentals. So IP addresses are 32-bit binary numbers, and these 32 bits are divided into 4 octets. So each octet has 8 bits, which you can say a byte. So for an example here, we have the 192.168.1.100 IP address. And in binary, it will look like the 192 will convert to 11 because it's 8. So you can see here 8 bits, and those 8 bits will translate to 1100 and 0000. Same for 168 and 1 and then 100. Now, how the binary places the values, the leftmost bit, which can be 0 or 1, a bit can be 0 or 1. And if the leftmost bit will be 128, then you have 64, 32, 16, 8, 4, 2, 1. And this will make more sense when we do our drawing examples
Yeah.
and as you progress the slides.
Yeah. And
So
to
go
your
ahead.
point, Mohammed, often, when I was learning subnetting, I remember counting with my fingers to think about the binary placements. So if
Right.
you have eight binaries or, eight binary spots within that octet and you want to get to 224, I remember going 128, 192, 0, or sorry, 128, 164, 32. Okay, that gives me 224. And I have three ones, then five zeros,
Right.
and so on. So you're gonna use your fingers when you get learning this.
Yeah. As you progress through, we're gonna go through more examples, and it's gonna make much more sense.
Yeah.
So here we have another like example. So converting decimal, which is our normal numbers from 0 through infinite,
Mhm.
like 192, which will be decimal in case. In binary, that is 128 plus 64, which we can see here, 128 plus 64. That will give us 192, and we can put that in binary. That would be 1 1, and then the remainder will be 0. And the zeros indicate that that particular decimal point will not be used for that particular octet. We can proceed to the next slide.
Okay. Yeah. So I'll talk about the IP address structure and classes. So IPv4 address structures, it is a 32-bit address space divided into network and host portions. Address classes, legacy, but still reference. And so I don't know that I would call it legacy because it's still a standard.
Oh,
Um,
sorry about that. Let me move back.
oh,
Yep.
it's okay. Oh, okay. So I don't
Mhm.
know that I would call them legacy because it's still definitely the learning standard today. But a
Right.
class A, which is a slash 8 network, will hold 16 million hosts, 16,777,214 to be exact. A
Mhm.
class B, which is a slash 16 network, will hold 65,534 hosts. And a class C will hold 254 hosts. Okay, so the binary representation for this, it is 0, XXXXX, and so on for the remainder of the octets. A class B, you will see a one at the primary binary and then a 0 on the secondary. And then a class C, you'll see the first two starting binary numbers to be 1, with the third being a 0.
Mhm.
So then and I wish it was referenced in the slide, Mohammed, but maybe it is further down. But a private address range, which is RFC standard 1918, and you will often hear that term, that RFC being, mentioned, RFC 1918. A Class A network is the 10 network. So it is 10.0.0.0/8. The Class B network, it is 172.16.0.0/16 all the way through 172.16.31.0. Then the Class C, it is the 192.168.x.x. So you can, and as best practice, I'm sure it was mentioned in our last video, is the 192.168 network is often used at home networks. So your internet service provider, if you are watching this video from home and you have not done anything to your home network, and you check your IP address with ifconfig or ipconfig, you'll see that you more than likely have a 192.168 address assigned to your machine. Because ISPs like using that, they don't expect you to build an enterprise out of your network or out of your home network. So 254 hosts is more than enough. Um, but anyways, yeah, moving on to the next slide.
Okay. So next we can cover the subnet masks and the binary logic. So the subnet mask function, it uses binary and operation to determine the network portion. So you have your subnet mask, which can be insider can be /24, 25, 26. And we'll see, as Carlos mentioned before, the class A network in RC 1918 is 10.0.0.0/8. So that's the subnet mask that we're referencing there. The subnet mask is also represented by 32 bits. It also has 8 bits per octet, and it can go up from 0.0.0.0 to like 255, 255, 255, 255. Here, we can see the /24 or 255.255.255.0 subnet mask, and that in binary will be all ones for the first 3 octets, and then the last will be all zeros. And here we can see the first 3 are the network portion of the IP address, if we had the IP address here. And the last octet is the host portion. Now, by default, that would be your normal normal subnet assigned to you by like an ISP, you can say. We can break that down smaller into a /25, let's say. And with that, we will get 255.255.255.128. And with that, we'll have 2 networks now. So /25. And how we can tell that we'll have 2 networks? Because the last bit is 1. And the bit can be 1 bit can be 2, can give us 2 decimal numbers, 0 and 1. And that's how you will know that we have 2 networks. And if we break that down more, and we have /26 now, which will give us 255.255.255.192. Now we can have 4 networks because we have 2 bits here. And each bit it represents two numbers. And so 2 bits will be 4 decimal numbers if we count that. And we can see here the binary AND operation, which can be used to tell what is the network portion or the subnet of the subnet or the host portion. So with the IP address of 192.168.1.100, which will be represented in binary like this, and the subnet mask of 255.255.0, which will be this in binary, we can tell what the network portion is when we do the AND operation. So in AND operation, you take one number, so you have 0 and 1 inputs, right? And in the AND operation, this 1 and 1, when you AND them, you will have 1. If you do 0 and 1 for, because the first two are 1, we will know those. Now the third bit here is 0, and the third bit here is 1 in our network mask. That would give us a 0, because in AND operation, a 0 and a 1 is a 0. So same here, and also 0 and 0 is also 0. So just for reference there, we'll go all the way down. So till where the subnet mask ends, that is here, the one after that, these are zeros. And we mentioned that before, that the zeros in the subnet mask are the host portion. So these are the host portion. And when we do the AND for the last bit here in the mask and the IP address, which is 1, this will give us the network portion now. So this is your network for this IP address. Right. And here we have a subnet mask rule here. 1 bit is equal to network portion. This is for the subnet mask. So this subnet mask, all these 1 bits, they represent the network mask, and the 0 represent the host portion.
Right.
Hopefully that is clear. As we progress more, we're gonna get more examples, and it's gonna make much more sense.
And Mohammed, if I can stop you at the slide.
Right.
When when I first started learning networks, this was the hardest portion
I
for me
agree.
to understand. This was, I mean, it was groundbreaking knowledge. It was too much at a time. But I think now, maybe 2, 3 months down the line, it just became secondhand nature. I would
Right.
see 255, 255, 255.0. I know that's /24. I know I can just remove that fourth octet and add a .0. That is my network ID. My broadcasts will be 255, and that's it. So for a lot of folks watching this that are maybe taking some course and are looking to strengthen their knowledge, this will become secondhand nature to you. It is not you know, at first it can be an overwhelming topic. It can be a lot of knowledge. But as you begin to understand and get those examples down, understanding this will become secondhand knowledge to you. And my best advice is just remember what the 8 binaries look like: 128, 64, 32, 16, 8, 4, 2, 1. And that's it. That's your 8 binaries. So
Right.
just as long as you can remember that, everything else will become secondhand nature to you. And I'm sorry that I stopped you there, Mohammed.
No, of course,
But
that's very valuable information there.
yeah.
So I think we covered this slide. We can move to the next one.
Of course. So calculating host addresses with binary. Okay, so there's a formula which is 2 to the power n minus 2. Why? Let's talk about what that means. The n in this number of host bits, so 0 bits in subnet mask, then subtract 2 for the network ID and the broadcast addresses. So if that previous example that Mohammed was, he had in his slide, that 0 is your network ID. That is not a usable address. Then your broadcast address, when your telephone, when your computer, when anything connected to that subnet sends out a broadcast, it'll send traffic to that 255 address if you're in a /25 network, /24 network, sorry. So that is not a usable address. That's why we subtract 2. So the binary example for this is a /24 subnet with 8 host bits. So 8 host bits meaning 8 binaries, 8 zeros and binary, 2 to the power of 8 minus 2. So that n is my number of host bits. Okay, in a /24 network, I have 8 host bits. So 2 to the power of 8 minus 2, it is 254 usable hosts. Say I have a smaller network now, and it is now /26. So I now use 6 host bits. 2 to the power of 6 minus 2, it is 62 usable hosts. What does a slash 26 look like? Remember those 8 binaries, 128, 192. That is 2 ones right there. That is 2 subnet bits. Okay? So that is 255, 255, 255, that 192. That is my slash 26. So 2 to the power of 6, it is 62 usable hosts. A slash 30 network. That is commonly used for point-to-points between routers. And as we go on, we will talk about what that means. But so you got 2 number of host bits, then 2 to the power of 2 minus 2, it is 2 usable hosts. And special addresses, okay? So you get your network address, that network ID, which is all host bits equals 0. Then that broadcast address, which is 255, and all host bits equals to 1.
Right. Okay, we can go to the next
Move on to
slide.
the next slide. Yep.
So network requirements, planning network requirements. Usually we have a corporate network, right? And how we can implement subnets and other technologies for a network. Network requirement analysis. So user access networks requiring interval routing, you need to count for those. Then you need to count for server farms or like servers, server racks in data center. You need to account for the WAN links. So the WAN links is what we are point-to-point addressing because they're going to be most likely between your edge router and your ISP router, right? So you will have a point-to-point addressing there. And that is where the slash 30 will come in, as Carlos mentioned earlier. And then you have network management for out-of-band network access. So that will be your management, VLAN, and subnets. And here you will have your management subnet. As for technical implementation, we'll have layer 3 switching for inter-VLAN routing. We implement ACLs for traffic filtering. We have DHCP scopes with subnet boundaries. And we also have static routing and dynamic routing protocols. These are all needed for your subnets to actually do something, right? You cannot just have a subnet and expect it to route to internet or access other resources. You will need to implement layer 3 switching if you're using layer 3 switches, like in our other video,
Previous
or
video.
previous video about VLANs. And you need to implement ACLs for traffic filtering. Also DHCP we mentioned as in our previous video for host address assignment or automatically host address assignment. You will use that with your subnet boundaries and also static routing or dynamic routing as needed in your network. We can go to the next slide.
Sure. So I'll talk about the binary subnetting process. The borrowing bit concepts can be a bit confusing. So basically, you take bits from the host portion and add it to the network portion. What this means is, and before I go further down the slide, what this means is I have a slash 24 network that I need to convert to a slash 26 network. What I've done there previously, that fourth octet that we mentioned was all 0, 0, 0, 0, 0, 0. What I've done is I've now turned it to a slash 26. So I have 1, 1, followed by 6 zeros, because I borrowed 2 bits from the previous host portion and added a 1 to them to make it a slash 26. So each borrowed bit doubles the number of subnets, okay? Each borrowed bit halves the number of hosts per subnet. That is correct. So what this means, because this can all be a bit confusing, what this means is each borrowed bit doubles the number of subnets. So if I have a slash 24 and I borrow 1 bit and I turn it to, previously if I had that fourth octet and a slash 24 network had 8 zeros and I borrowed 1 bit at the beginning, now it's 1 followed by 7 zeros, you now have a 1, 255, 255, 255, that 128. What that means is I doubled it because my 1/24 network has now become 2/25 networks. So I've doubled the number of subnets. Each borrowed bit halves the number of hosts per subnet. Before I had 7 bits, before I had 8 bits to use for the host portion, which gave me 254 usable IP addresses. After my change, that I've become a 255, that 128 network, that means I have that 254 number. So now I only have 254 divided by 2 is 126 number of
126.
hosts usable.
Right.
So the example, and I guess what I just mentioned is referenced below. So
Yeah.
an example is I need to create 4 subnets out of my /24 network. Okay, so let's calculate the subnet bits needed. Okay, so I need 4 subnets. So 2 to the power of 2 equals 4. We know that. So we need 2 bits. The original, as you can tell, and if you want to move your mouse, yep, is the original, those 8 bits in the fourth octet. Remember, each set of 8 binaries is an octet, so that you have your first octet, your second octet, and your third octet, and your fourth octet. It is a /24. In the new subnet, we will need the exact same 3 first octets, and then because we borrow 2 bits, it becomes 1 1 followed by 6 zeros in the binary. So we have /26. What this means, out of the /24 that we had originally, we've created 4/26s. You may be wondering, when am I going to need this? When is this going to be usable in an enterprise network? And the truth is multiple times, because especially if you're referencing public IP addresses or your enterprise is using public IP addresses, you don't want to waste it. You want to save your resources. This is used maybe in a server farm that's going to be, you know, less hosts than expected. Maybe you allocated a /24 and they need to implement some sort of microsegmentation or firewall policies. So now you created 4/26 networks. And there's many examples that I can think of that this would be used. So the step 2 is we calculate the subnet increment. So the remaining host bits is 6. The increment is 2 to the power of 6, which is 64. So out of that 254 usable /24 that had 254 usable hosts, you now created 4 separate networks, each in their broadcast domain, each that can have firewall policies around them, of 4 subnets with 64 hosts usable in.
Okay. Great. Let's move to the next slide. So binary subnet calculation example. I think we covered that earlier, but it's going to be another example. So this time we have a 192.168.10.0/24. And again, we need to get 4 subnets. And like Carlos mentioned before, we have a /24 and we need 4 subnets. So we're going to do 2 to the power of 2, which gives us 4. So that means we need to borrow 2 bits from the host section, right? So we do that. We now, our new mask will be 192.168.10.xx, which denotes that that's our new network bits. And the remaining zeros indicate our host bits. And now we have a new CIDR of /26. Now, these subnet enumeration in binary will look like this: 192.168.10.0000000, all 8 zeros for host bits. And this is going to be our first network out of the 4 networks that we just created. And this will go from 10 to the 0 up to 63, right? And again, we have to account for 2 IP addresses for our host, for our network ID, and then the last one for our broadcast address. So in reality, this will be 62 addresses. It says 64, right? Then our next subnet will be 10 dot in binary, it will be 0, 1. And the 1 indicates that it's 1 in decimal. So it will give us 192.168.10.64. And the subnet CIDR again is /26. Again, 1 indicates 128 in our binary that we mentioned, bits we mentioned. So 128, 64, 32. Then we have 16, 8, 4, 2, and then 1. So now this 1 indicates 128. Since it's the leftmost bit, it will be 128. The next one is 64. So that's why here we had 64. And this time our next subnet is 128 and then /26. And then the last one has both one and the both one bits. So that will be 128 plus 64. So that gives us 192. And that's our last network, subnet that we created with the slash 26. And again, at the bottom, it says it's 64 addresses if you count them, but it's actually 62 usable addresses by the hosts. Because the first one, again, is for the network ID, and the last one is for the broadcast. We can move to the next slide.
Yeah. So the binary address analysis. So for subnet 192.168.10.0/26, which in binary, and I'm gonna do this is let's look at that first octet, 192, which is 1 followed by 6 zeros. We know 128 plus 64 equals 192. Okay. Followed by the next octet, which is 10101. So what does that mean? The 128 bit is on, the 64 bit is off. So I skip on to the next, which is 32. Okay? So it's 128 plus 32. The following bit, which is 0, that would be 16, so it's off. Then you get the 1, which is the 8, that's on. So let's do the math. 128 plus 32 plus 8, that is 168. And that's where that number comes from. Let's look at the last one. Okay, so starting from the left, 128 is off, 64 is off.
Oops, sorry.
It's okay. So 128 is off, 64 is off, 32 is off, 16 is off, 8 is on. Okay, so 8, let's see the following bit. 4 is off, so 2. So let's see 8 plus 2, 10. Then the following octet is all zeros. So we ended up with 192.168.10.0/26. Okay, so let's see the address breakdown. The network ID on this would be 192.168.10.0 because we know that would be it would be much different if it was a 192.168.10.75 because then you would move on to a different network ID. So that 0 is your network ID. The first usable is going to be that one address. Then the last usable, which is 192.168.10.62. Your broadcast would be 192.168.10.63. So let's think about that. This /26 network, is there another /26 network that follows this? The answer is yes, because the following network would be 192.168.10.64.0/26, which the first usable address would be that 65, followed by the last usable address, or sorry, the broadcast of that 127 to create a new network that is 192.168.10.128/26, followed by the first usable IP of 129, and so on and so on and so on. So the binary verification for this would be 62 in binary, which is the highest usable host number, 63 in binary, which is all host bits equals 1, which would be the broadcast, and then 64 in binary, which is the next subnet starts here. So take a look at those binaries and let's see what it means. You'll see that the 62 in binary is the highest usable host number because that's right before that eighth bit. That eighth bit that's set to 0, notice how that is the last one. So if you add that one bit, it becomes your last one because you already used 2 for the network ID portion, or sorry, for the subnet portion. So understanding that, again, this can be very overwhelming, but as we get into the examples, we hope to simplify this. This is just the theory of what we'll talk about.
Right. This takes us to our last slide, which is on variable length subnet masking, also known as VLSM. So what is VLSM? It is the technique that allows different subnet masks within the same network It enables efficient IP address allocation by creating subnet by varying address sizes, eliminates the waste of associated with fixed length subnetting, which we have been doing so far with breaking down a /24 into multiple four, or in our example before was four subnets. And that's basically VLSM. We have been doing that this whole time. What are the key benefits of this? We get address conservation. So we only use the IP addresses that we need. It gives us a hierarchical diagram. So it supports network summarization, which again, in future videos, we will learn much more about network summarization and stuff like that. It gives us flexibility, so different subnet sizes for different network segments. So we could have that /24, we break that into 4/64s in our example, like we did. Now, what are the requirements for that? So we'll do classless routing protocols. So like RIP, EAGRP, OSPF, BGP, and routers must support VLSM. Now, every single new router you're gonna ever use is gonna support VLSM. And then example, like we had before, 192.168.1.0/24, it can be subdivided as a sales department. So you have 192.168.1.0/26, 62 hosts for those. Then the IT department can again take the next subnet in the 64, it starts from 64, and it can break down into multiple subnet 27s. And then you can have WAN links as /30s. So we could take one /24 and break that into multiple /26, 27, or even /30s. And VLSM is used in every single enterprise you will ever look into. With that, we conclude our PowerPoint slides, and we can move to the drawing slash, I think, more examples, I would say. Let me stop sharing. Carlos, are you gonna share? You're still muted. That
Oh, sorry. Okay. Let me replace the current share. Yes. Remarkable screen share. There it is. Are you able to see that?
I can see that, yes.
Okay. So I think the first portion of what we want to understand here, that there are classes, right? We got the 10 network, which is class A. We got the class B, which is 172.16 through 172.31/16. Then the class C, which is 192.168 that 0/24. So
Right.
what this means is we'll write an X here because it does not have to be a 0. It'll be whatever um, number you want it to be. So like if you put a 20 there, a 35 there, whatever you want, that would work. Okay, so let's get into subnetting. Subnetting, which can be intimidating when you're talking about binaries and all that. I'm sure we all know that in the real world, it's not very often you'll be using those binaries, but it is often that you will be subnetting because
Right.
you'll get tasked with standing up a new environment, whether it is in AWS, Azure, whatever, where you will have a /X network that you need to divide into different Azure landing zones, AWS VPCs, and it depends. So saying that subnetting is not needed in the real world, it's false. It is very
It's
much
false.
needed. It's not very often you'll be looking at binaries and things, but again, the further you strengthen your theory as you're beginning your network career, it'll only help you in the long term. So let's see. I'll create a subnet example. We'll start with 10.158.0/24. So what does this look like in binary? It is a very, um, you know, that looks like a tough thing to have, right? But it's not. Let's start with the 10. Okay, so the binary for 10. The binary for 10 will be, we know that, let me write down my binaries here. So we will have 128. We will have, I'm sorry, let me do that. 128. we have 64, we have 32, 16, 8, 4, 2, 1. So this is your binaries here, okay? When something is 1, that means that is enabled. When something is 0, that means it is disabled. That bit is disabled. So let's start with the 10. The 10, we know that this will be a 0. So 0. We know 64 is 0. We know 32 is 0. 16. The 8-bit will be enabled. This would be a 0. This would be a 0. This would be a 1. I'm sorry. This would be a, there we go. This equals 10 because we have 8 plus 2 equals 10. Let's see 36. 36, that looks a bit more complex, but it's not. So let's see. 36. Oh, why did it write like that? I'm not sure. 36. Okay, 36 is 128 is much higher than 36, so we know that's going to be disabled. 64, 32, that fits in, so we set that in. 0 and 16, so we just need 4 to go. 0, 1, 0, 0 equals 36, because we have 32 plus 4 equals 36. Okay, that 158 number. 158. Yeah, 128 fits in there. Okay. 64. No, that's too much. Then 32. Let's see. What is 128 plus 32? 128 plus 32 equals 160. So that is just overboard of what I need.
Right.
So it will unfortunately have to be a 0. But 16 will definitely fit in, and we end up with 144 after we enable that. So we only have 10 to go. We only have 10 to go. Or sorry, is it 10 to go? 12 to go.
Yeah.
Yeah. So
Wait, no, it's 14 to go.
14. Yeah. Sorry, I'm
Yeah.
looking at the numbers here.
Okay.
Okay. So 128 plus 16 equals 144. Then we know we can add 8 as well because that puts us as 152.
Right.
Then plus the 4-bit here, which will set us at 156. Okay, so far we have 128 plus 16 plus 8 plus 4 for 156. So all we need is that 2-bit, right?
Right.
So once we enable that, we have 158.
58.
Then the easiest one of them all, a 0.
Is that 0?
So just
Everything
0,
is 0.
0, 0, 0, 0, 0, 0, 0 equals 0. So look at that. It definitely took it's not easy to do this. It's really not.
Right.
I mean, I've been I still struggle to do these because
Yeah.
keeping track of all these numbers and all that, it's not easy, but it is good foundation knowledge to have.
Yeah.
So that is the
Carlos,
binary.
I have one question. Can you put
Mhm.
the base numbers to like 2 to the power at the bottom so that it's also there, like in
Yeah.
the lines, yeah, at the bottom. So
So
to the 8, like that.
so 2 to the power
This will
of
be 7.
let me write the formula here. 2 to the power of n
Yeah.
equals. So right here, to Muhammad's point, let me go ahead and highlight this right here. What would this be called, Muhammad? My subnet bits?
This will be your host bits
Okay, my host bits, exactly.
because you have a slash 24. That's why.
Yeah, so this is my host bits. Host bits. So these are my host bits, and we have 2 to the power of 8, which is minus 2. So this would be 256, but we do
Right.
minus 2, which is 254. So 254 usable addresses.
It's gonna be 2 to the power 7. It's not 8 because we start from 0. That's why.
2 to the
Right.
power of 7.
Right. Or am I wrong?
I think you're wrong.
I'm yeah, sorry.
Yeah, you're wrong.
Okay.
Sorry. It's okay, we're all
Yeah.
wrong.
Mm-hmm.
Yeah, because yeah, 2 to the power of 8 is 256.
Okay.
Um, okay, so let's do another example, and this is good. I mean, again, the point of this is for us to also strengthen our foundation,
Right.
right? So it's good. We'll do another more complex example. So I'll go with 10, that 0, that 128, that let's do here 17 slash let's do 24. So let's find the network ID. Let's find the first usable address. Let's find the last. And let's find the broadcast. So how would we do this, Mohammed? If I know that this is a 10, so we'll do 10 dot 128 dot 17. Oh, sorry, 10 dot 0 dot 0 dot 128 dot 17 on a 255 255 255 dot 0
Mm-hmm.
network. Oops, and my handwriting is terrible, so I apologize. Okay. So I would be going about finding this. Again,
What
as you
uh,
go.
let me go ahead. So
Mhm.
what the subnet tells me, the first three octets are network. So that tells me that the first three octets is the network. So 10.0.128 is the network part.
Mhm.
And the zero and the end tells me that the last octet is the hosts portion.
Okay.
So um, now, since it's a slash 24, I know that because 255.255.255. So first three octets that, and it's octets. So 8 times 3, you could say, is 24. And the last one is the whole subnet portion for host. I know that the first um, decimal is gonna be the first usable address. So dot zero, it will be the network ID here.
Okay. So let's put that into uh that 0 will be the network ID. Okay.
Right,
So because you're saying that you know that this is this, right?
right.
So that 0 will be the network ID of that
Network
network.
ID,
That is
right.
correct. So let's do that 0. So your network ID is 10.0.128.0.
Mhm.
Okay, that would be your network ID. So what would be
The
your first usable IP?
since zero is our first address that was usable, but it's not usable because it is being used by the network ID.
Mhm.
The first will be dot one.
Okay.
So 10 dot 0 dot 1. You said you put 10 there.
Oh,
It's
yep.
10 dot 0.
Yep.
Yeah. Dot 128 and then dot 1.
Mhm.
And then same for the broadcast, since broadcast is always the last usable
Mhm.
IP address. And in this case, since this is a slash 24, that means the last whole octet will be one once for
Mhm.
the broadcast address. So that will be 255, since
Okay.
all of them are one.
Yep.
Since all the bits are going to be one, and we know that because broadcast address
So
always
we
has
know that the
all
last
the
is going to be 254 because that's before the last bit. Mm-hmm.
right.
Yep. Yep.
And then for broadcast will be 255.
Exactly.
Perfect.
So let's see. Let's put this into binary so folks watching this video can understand what you just did. For most of it was done mentally because you look at a
Right.
64 and you're already able to identify, okay, this. But on a binary, it would look something like this. Again, let me go back to 128, 64, 32, 8, or 16,
16, yeah.
16, 8, 4, 2, 1. We have the 10. So we know that's 0, 0, 0, 0.
1 for the 8.
Yep. 1, 0,
And
1,
then 1 for,
0.
and that is 10.
Okay,
Yes.
great. Then the 0 here, which is all just 1, 2,
Zeros.
3, 4, 5, 6, 7, 8 zeros. Then we got the 128, which is very simple.
Yep.
Because we know 1,
Yep. And all
0.
zeros.
Then you get your slash dot 17. So that 17 is going to be, let's see, 0, 0, 0, 1. Because it would be 16, 0, 0, 0, 1. So that is 17, right?
Mm-hmm. That is correct.
Okay. So we know that looks like that. And now you're saying that you know because it's a slash 24. In a slash 24, this is all supposed to be zeros here, right?
All right.
This is all supposed to be zeros. That's what Muhammad is saying, that this is all supposed to be zeros. So we know that the first usable address would be the one with the outermost right bit set to 1, which is that 1. Then the last would be the outermost left bits set to 1 with that right bit set to 0.
0.
Then the broadcast would be all
All
of those in that octet set to 1,
1.
just 255. That is good. Okay, so that is great. I think it is the slash 24 network is a very easy one to understand, right?
Right.
I think it is much more complex when you begin talking into slash 22. So we'll do a
Yeah.
slash 22 for the folks watching this. Um, I'll go and start with a 10, that 43, that 253, that 18 slash 22. Okay. So we'll start off with what is our network ID. Again, I'll write it at the bottom. What will be the network ID? What will be the first usable address? What will be the last usable address? And what is the broadcast of this network? Okay. So we're going to start off by writing this in binary. Okay, per usual. So we'll start off with 128. We'll start out, well, oh, I'm sorry, I'm going to move them a little bit more to the right so I can 128 followed by 64, then 32, then 16, then 8, 4, 2, 1. So we'll start off with our 10 here, which we know will have 0, 0, 0, 0, 1, 0, 1, 0, 4, 10. Then our friend here, 43, which is 0, 0, 1, 0, 1, which is now 40. Okay, 40. Then we just need a 3. So we need 1, 1, 43, right?
3.
Okay.
Correct.
Then we followed by 253. So 253, we'll do 2, 5, 3, which this has to be set to 1, 192, 224, 240, 248, 252, 253. Okay.
Correct.
Then 18 set to 0, 0, 0, 1, 0, 0, 1, 0, 18. So let's look at this /22 portion. Okay. So what does /22 look like in subnet form? It is 255, 255, 255. Nope, nope, not 255. So we know,
Yeah, it's gonna
yeah,
be
it's going to be 252.
correct.
252, that's 0, that's 0.
You had
Oh,
a
I
you
wrote, yep, yep.
yeah.
Sorry. I thought of it, didn't write it. 252, that's 0. Okay. So what does this mean, Mohammed? If you want to walk us through this, I'll write out your words.
So now this time our network portion is up till the 252. So that means I believe that will be
So let me write out a subnet mask
yeah,
binary, right?
yeah,
So we know
in
that this is going to be 1, 1.
right.
Oh boy. Okay, that's going to be a minute. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6.
That's it.
0,
Zeros.
0, 0, 0, 2, 3, 4, 5, 6, 7, 8.
All right.
So let's do this. We'll highlight and say this portion here, right? This portion here. What would these ones be called, Mohammed?
This will be your network side.
Okay.
So
These are my network.
network, yep.
Network bits.
Network bits, yes.
Okay. Then this other portion here is going to be my
Host bits.
host bits, correct? Host bits. And I think I'm actually going to scale this a little bit. So from here to here. There we go. Okay. Okay, so what does this mean?
This means that your hosts have you have a lot of hosts now compared to your /24 before, since
Mhm.
you got those extra two um, bits there for the host section. And we learned that before, that when you add or remove a bit, it increases or decreases, right? And it's double, always double. So in this case, since we increase the hosts bits more, it's gonna double or quadruple in our case, because we have two bits, right? So it will be, instead of 254 or 255 or 256 hosts, it's gonna be a total of 1,024,
Okay.
since it's gonna multiply essentially, right?
Right. So let's see how you found that. Let's put that into here. Okay. So we'll do, let me see. We'll do this portion here, 2. Oh, I don't know why it writes like that. 2 to the power. Oh, am I writing with highlighter? Okay. 2 to the power of n minus 2. So in this case would be 2 to the power of my host bits, which is,
10.
I have 8, 10 minus 2, which would give me 10. What was the number? 1024 or
Yeah, 1024. Yeah.
1024. So it would be 1026 then the minus 2.
No, 1024 is including the broadcast and
Okay,
everything. Yeah,
so we'll do 1024, 1022
1022. Yes.
usable. Okay, good. So with that being said, let's look at the third octet, right? Because the /22 cuts into the last two bits being zeros.
Right.
Let's look at the third octet, okay? So I'm sorry, yeah. So in the third octet, the last two bits are zeros. Then the increment block size is a 4 because we think of there is a magic number. There is a magic number that we haven't talked about that is called 256. Okay, that magic number, that 256, we subtract that by this number here. This number here. So that 256, we'll call it our magic number. So 256 minus 252 equals 4. So our network increments every 4 in the third octet. Okay? So every 4. The
Every
third
4.
octet increments every 4. So what does this mean? This number will change every 4. Okay? So the third octet of the IP 253 multiples of 4. So the nearest is let me think. Let's think about that, right? It increments every 4. So you got 4, 8, 16, da 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 da, up until you get to 252. And this is one of the more complex ones. So it'll do 252. We'll do 248. So it'll come as this. Increments of 4. So this will put us here. Increments of 4 of 4. So we'll do 40, 80. We know 160 will fit in. We know basically all these numbers, right? 40,
Yeah.
80, 160. We know that 200 will fit in. We know 240 up until 252. So I'm sorry, let's do this. 248, 248, and 252. So that is our closest one, right?
Right.
That is our closest one. So magic number, let me highlight this because that is a very important thing. So the 252, 256 is the magic number, and then 256 minus 4. So that means our network ID changes every 4.
Every 4.
So we're going to go down here, the increments of 4. We know it's 40, 80, 160, 200, 240, 248, 252. Okay, so the block is 252 all the way to 256. But we know that 256 number is impossible when you're talking about, IP addresses. The maximum is 255. So really, you would be looking at 252 through 255. So the network ID for this would be 10.143.252.
So wouldn't this be 251, you think? Because we start from 0, right? Or
Yeah, but it changes every 4.
but it
So
changes every 4.
it's
Okay.
good you're asking this question. So it
Yeah.
starts from 0. So let's do this. I'll draw it out, and it's great you're doing that. 10, 10 to 10. Oh, sorry, 10.43.253. Oh, sorry, that 253. 10.253. That 18 slash 0 slash 22. So we know that this goes to be 252, right?
Yeah.
255, that 252, that 0. So you subtract this here from 256 minus 252 equals 4. So it changes every 4.
Very 4. Okay.
So that means 10.240, sorry, 10.43 that 0 slash 22 is the first network. The same applies to 10.43 that 200 that 0 slash 22, then 10.43 that 248, and then 10.43 that 252. This is our network here.
Yes. That okay, that
That is
makes sense. Yes.
Yep, that is our network here.
Agreed.
So we ended up with the concept of this IP address, right? Falls within this network.
Right.
So now much easier to do.
Yeah.
You get the network ID first, last, and then the broadcast. Okay, so the network ID first, last, broadcast, which is
10.43.
the network ID is this here,
Yep.
10.43.252.0
Yep.
slash 22. The first is 10.43.252.1.
Mm-hmm.
Last is 10.43.255.
Oh,
That
250.
254. The last is 10.43. That 255. That 255 slash 22 slash 22 here slash 22. Okay. And I'm sure as everybody watching this is complex, right? This is
Right.
complex math. This is remembering that 256 magic number. Once you're able to think of that magic number, it'll all get easy. Okay. Just I think for what it's worth, Mohammed, we maybe do one more example of
Okay.
another subnet mask, that is referencing that magic number. Then we'll do one of the variable length subnet mask, and we can call it off with that. Um,
Yep.
I'll do another problem here. So what we'll do is we'll think of another 137 that 88 that 43 that 65 slash 18. So we're getting into those complex ones. So what this means and what this looks like, we'll first turn the IP address into binary. Okay,
Mm-hmm.
see how we do that. So the binary of this would be, let me go ahead and, so the binary equals, we'll do a 128, 64, 32. We'll do 16, 8, 4, 2, 1. Okay. And we have 137 here. So 137, we know that's going to look like 1, 0, 0, 0, 1, 1, 1 equals 137, right?
Yep.
Okay. Then the next one is 88. So 88. Oh, sorry for that 8.
Actually, I think that is wrong. You don't need the two there.
Oh, I don't.
The
Yeah, you're
yeah, the
right.
bit for two.
Yep. Yep, you're correct. Because 128 plus 8
Yeah.
is 136 plus 1. Yeah, sorry. I was thinking of 139, I think. But okay, great. Thank you. Good find.
Yes.
So you get 0 here, 1. Okay. Then this will add a 0. So 64 plus 16, that gives us 80. Okay. So here we add an 8, 88. Then we'll do 0, 0, 0 equals 88. Because we got 24 plus 64.
All right.
Okay. Then we'll do the 43, which is 0, 0, 1. And then we just need 11 more to go, right? So to get to 43, so we'll do 0, 1, 0, 1, 1 equals 43.
Mhm.
Then the 65, which will be that 64-bit set to 1 with the 1-bit set to 1. So 65, 0, 1, 0, 0, 0, 0, 0, 1 equals 65. Okay, so that's what our IP address looks like in binary. Then if we go ahead and turn this subnet mask into binary, we know that /18, oh, I apologize for that. Let me do a /18, would look like 255, that 255, then 192, that 0, right?
Yep.
So what does this look like in binary, Mohammed? We'll do one. Oh, I apologize for that. I think I pressed too hard. 1, 2,
Yeah.
3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so back to what we were talking about here. This portion here is called our network
Network
bits.
portion. That's
Network portion, network bits. Network portion, and then this portion here is called or host bits or host bits. Okay, so for the sake of how many usable IP addresses here, we know that we have 2 to the power of 8 plus 6. So 2 to the power of
14.
2 to the power of 14. That gives us I think it should be 16,384 minus 2. So let's do that. We'll write our formula here, which is 2n, 2 to the power of n minus 2, which is 16,382 usable addresses. Okay. All right. And then to find our first network ID, first, last, and the broadcast, we'll have to look at the magic number that we were talking about earlier. So this 192 number, we know that the third octet is the usage point on this subnet. We'll create the 256 magic number. So we'll do 256 minus 192, which gives us 256 minus 192, a 64. Oh, 64. You 64. So we know that network changes every 64. on the third octet. Okay, so our IP address was 137.88.43.65. So let me write it down here again. 137 dot 8843
65
slash
80.
18. Thank you. Okay. So this third octet, does that fall within 64? That's what you got to ask yourself when you're doing these problems. Does that fall within 64? Yes, it
Yes.
does. So we know that we're going to get 137 that 88 that 0 that 0 slash 18 138 that 88 that 64 that 0 slash 18 137 that 88 that 128 that 0 slash 18 137 that 88 that 192 that 0 slash 18 and so on. Okay, but for what we care about here, which is here, we know that the first network ID is that. So we'll go ahead and write 137.88 that 0 that 0 slash 18. The first usable, which to your point would be that first binary bit set to 1.
Right.
So it would just be 137.88 that 0 that 1. Then the last would be 137.88. We know that this goes all the way through to that 63 because it changes every 4. So we know that third octet is the last usable is going to be that 63, 37.88, that 63 because it changes every 64. So the last usable is that 64 address. So that is going to be it, that 255 here, because all of our host bits are going to be set to 1 on that fourth octet. That 88, that 63, that 255.
That would be
Sorry,
254.
254,
Right.
yes, yes.
Right.
254. And then the broadcast will be 137, that 88, that 63, that 255. And with that, it is not easy at all. Look at that. Look how much we wrote just for one problem.
Yeah, I
But
agree.
my recommendation for everybody watching this is practice. Just one day, practice, practice, practice. Eventually, your brain is just going to remember everything out of so much
Right.
practicing that you're going to say, oh, okay, slash 18. I know the left one is 255, 255. I'm working on the third octet. Let me see. 3 bits set to 1. 192 is 2, then plus the other 32, which is 224. So I know it's going to be 255, 255, 224. And it's really just going to be, you're going to be able to map the CIDR to a subnet and just know what it means.
Right.
So variable length subnet mask. Um, I believe it is you know, a variable length subnet mask, what it really is a method of subnetting that allows you to divide an IP address in space into subnets of different sizes. So right now, if you notice what we've been doing here, this is subnetting. This is almost what I would like to say fixed subnetting, right? Like we created all these different slash 28s, or I'm sorry, slash 18s that we know that's the same fixed range.
Right.
Okay. But with variable length subnet mask, and where this really comes into play is when you're assigned a public address or a public subnet by an ISP, by Aaron, or whatever, and you then have to analyze what your requirements are. So you're going to have to segregate that for the DMZ. Maybe you have other web services that need to be accessed externally, and you have 50 hosts here, 25 hosts here, 10 hosts here, and so on. So what VLSM does is traditional subnetting uses a fixed length subnet mask where all subnets must have the same prefix length. So everything has to be /24s, everything has to be /25s, and so on. But with VLSM, you can assign smaller subnets to networks that don't need many hosts and larger subnets to networks that do, making for more efficient use of your IP address space. So let me talk about an example here. So VLSM. Uh, let's just assume I'll use an easy example, right? With 192.168. Actually, no. I'm gonna use a public IP address, and
Okay.
because this is more likely where you used to use VLSM as you're allocating these resources to your enterprise. So we'll do 128, that 150, that 143, that 0/24. Okay, I'll use that as an example. So let's say that I have a requirement where my DMZ, we'll call it DMZ. DMZ needs 100 hosts. My client needs 50 hosts. Let's see, my web server, which you would want to put, DMZ needs 25 hosts. And we'll say I have just a honeypot because I do some security researching for my enterprise. So I'll call my honeypot. I only keep 10 hosts there. Okay. So this is my requirement for enterprise. The first thing that I'm going to do is I want to allocate the largest subnet first, which is that 100 requirement at the DMZ. So let's think about that. We need 2 to the power of what uh, will give us that number that suffices that.
That would
Say
be 7.
2 to the power of 7. That is correct because that would give us that 128 addresses, 126 usable. So we end up with something like, let's see, first we'll use this requirement, right? That's the way you want to approach VLSM, is attacking the largest subnet first. So let's see, we end up with 128. That 150, that 143, that 0/25. Okay, so the range here, it is the range for this is that 1 through that 126. Through that 126. I'm not going to write out the whole subnet.
Right.
Okay, we'll approach the secondary largest subnet first. Okay, so we know that subnet B, or my client subnet, needs 50 hosts. And when I say client, I don't mean computers. I mean that I am hosting something for somebody that pays me. They have 50 hosts, so the nearest power of 2 is 64, right? So that would be, let me think, 2 to the power of 6. 2 to the
Yes.
power of 6, correct. So we'll use 6 host bits, which would turn 2 extra network bits on that fourth octet, which would give me a /26. So we would do 128, that 150, that 143. That, you'll notice how here I ended, right?
Yeah.
Because that 127 would be my broadcast. That 128 would be a new network
It's
ID.
the new network
So I'm
ID.
going to begin touching that new network ID of 128. So it's going to look something like, okay, I'm going to create that 128/25 26, which gives me a range of that 129 through that, let me see, that 190, because it ends at 192. At 192 on a /26 network, it changes every 64.
Right.
So it would give me a 192 maximum. 190, so 191 would be my broadcast. 190 would be my last usable address. Then we'll continue that same approach of having the larger subnet. That would be this the 25 host requirement. So we know my 25 host requirement needs 25 hosts. The nearest power is the 32, which
32.
is 2 to the power of
5.
2 to the power of 5. Is that right? I think no, 2 to the power of 6. Oh no,
So
sorry. You're right.
5.
You're right. Yeah, 2 to the power of 6. Oh, 5. Yeah, yeah, yeah. Yeah. I'm sorry. Yeah.
That's fine.
Let's see. 2. Yep. Okay. So let's see. 32, 2 to the power of 5. Okay. So 2 to the power of 5. Then we get a /27 then, because we are essentially using
3.
3 now. 3 network bits with 5 remaining on the host portion. So so we get 3 ones, 5 zeros, right?
Right.
So that those zeros you put to the power of. So we become 128, that 150, that 143. And we know this ended at 192.
192.
So my network here would be 192/27. Okay, which would be my first usable is that 193. And because it's a /27, using the same subnetting procedures that we did previously, we can find out that the last usable would be 224. So it goes all the way up to 224. So the last usable would be 222. 222. Okay. Then my last requirement, which I only need 10 hosts. So subnet D, which is my honeypot, where I'm doing all my security research, only needs 10 hosts. So the nearest 2 to the power of is 16. So 2 to the power of 4.
4.
Which requires, that would give us a 128, that 150, that 143. That we know that this ended at 224, so that is my new network, 224/28. Okay. Then the usable range here would be 225 exactly. And the last usable being using the same subnetting would be 238 exactly, because the network would change at 240.
Right.
Okay. And with that, that is VLSM. So we used what we've just done is we use that same /24 that our internet service provider allocated to us to allocate to different segments of our network. So instead of putting everything under that /24, and now my honeypot can talk to my client and to my DMZ and to my web servers, which we would not want that. We've allocated it to different subnets, to different broadcast domains, and in essence, to different VLANs. Well, I'll say different VLANs because you'll want to split it out like that, right? So it all connects as you learn the VLANs to subnets and all this. And yeah, that pretty much concludes our video
Yep.
for today. Thank you very much, Mohammed.
Yeah. No, thank you for all the hand drawing and everything.
Yeah, yeah. So if anybody has any questions, just drop them in the comment, and Mohammed and I will be happy to answer anything.
Right.
So thank you. Hope everybody has a good one.
Thank you.
Thank you.